Okay, hi guys. Hope you're all doing well. I've been messing around, been talking a lot, thinking a lot, blathering on a lot as I do. Now we're in COVID lockdown. So here we are on the Facebook page. I must update the graphics on this page. They're pretty awful. I don't mean the games, by the way. I mean the title stuff up here. If you've got a better title, if you want something to do, be more than grateful to have a look at it. It's always bugging me actually to update the cover titles. I guess they've been there too long. So one thing we were talking about last time was this pre-processing tool idea. So we can find the conversation in here. Been making a few little birthday videos for people. These are in PB2, by the way, if you want to have a quick look at one. Just turn the volume down. Maybe not off, but some of it's post-processed, but most of what you see is just in PB. The warping effects there are done with the video editor itself, but all the particle effects and the waviness of the birthday message. The blur is done in the video processing as well. That source code's on the forum up there somewhere. I won't bother looking for it this millisecond. You can find it on the boards as usual. So there's a frozen planet. Yeah, I think it was just some game I like to look of that had a kind of a traditional multi-layer look about it that was probably blit friendly, I would have thought. So here we're talking about these pre-processing ideas. Got a bit of mucking around here. I'm going to get to, is it in this one? So a comment about object orientation. Here we're talking about, I'm talking about some of the other converters I've written over the years. Some are very specific to what they do. In other words, they convert a particular program from one dialect into something else. So I might use a lot of a certain command or a function. I go through and write a bit of code that quickly rehashes that bit of code to save me having to do it by hand. Which can have great results just by doing that. But if we fire up the IDE PB, so this is a bit of a, this doesn't do anything interesting at the moment, but the idea is that this will be, well, if we can get it to work anyway, the idea of this will be that the process is called like this. So the IDE, where our source code is written, and it calls the PB compiler as it does when you hit F5, for example, or F7, or whatever mode you want to compile in. And what you'll do is you'll put, like, in the title, this is not set up at the moment, but in the title, the idea is that you might do, here you might put like a square bracket and you want it pre-processed, pre-OO or something like that, I don't know, whatever it happens to, whatever the keyword we use. That way the compiler can do a look at the project file, and rather than scanning through all the source code to see if there's anything that needs pre-processing. It's a bit of a hack because we can't update the IDE. Anyway, so we could pass this message. We could, we have a message in screen title for compiler to pre-process. Right. So when the compiler sees that in the project file like that, it goes okay, and then calls a secondary tool. Whatever this tool is, it will be defined in a list of tools that will be found in your PlayBASIC folder. If we go ahead with this thing. So what happens is the compiler calls, you know, the OO preproc, or OO compiler in this case, we'll call it. That will then spit out. So it creates, or it preprocesses that chunk of code and removes all of its custom syntax and creates a version of the code that will compile with regular PlayBASIC. So classes are converted to types, methods are converted to functions, this kind of thing. So it creates, you know, PB code of or PB compatible code, we'll just call it, you know. Once that code's been created, the normal regular PB compiler takes over, compiles and runs that code, and if anything breaks, there's an error or something like that, we have to just return an error back to the IDE. Because the IDE and the compiler are really not aware of what the preprocessing tools are doing, we need to provide the PB compiler, I know it's getting confusing, I'm sorry about that, with a line map. And that's really just because, let's say you've got a bit of code here, you know, print hello world. Awesome. But if I have some bit of code in here that you know, I might have a preprocessor that generates me a whole select case block, and all I do is maybe in this code here I just go 1, you know, and I give it a function name, you know, bill, you know, what can we call that? We might have like fast select or something like that. End fast select. Or we just have a list of these things like this, you know, and our variable goes here. And we just have a list of the functions we want it to call, you know, bill 2, 3, 4, whatever. So the preprocessor would run through and detect this special syntax that doesn't exist in PlayBASIC, but the preprocessor is going to convert to something that PB understands, and inserts a new block of code replacing this stuff here. If the new block of code is longer than this, what have we got here, 8 lines, and we have code following this, you know, sync or something like that, wait key or something, fantastic. And let's say we have an error occur in one of these lines above this, we try and draw a sprite, you know, we try and draw a sprite 100, which doesn't exist. That would pop a runtime error. If I've gone and modified this piece of source and inserted a bunch of lines or taken lines out, when the runtime hits this error and goes, well, the line that this piece of code is actually on when it gets compiled finally won't be 50 anymore, it might be 150 or 250. So it needs a way of remapping the final line back to the original line so the IDE can understand what the hell's going on. If an error occurs on lines that don't exist in the original source code, then we have to map them back, maybe just the you know, to the initial statement or something like that. That would be a problem. That would be annoying for people using the preprocessing tools, but I guess once you got used to how your preprocessor works or what it does, that would be okay. But I kind of wanted to have a go at doing something that kind of gives you, it won't make it object orientated, but it's giving you kind of a syntactical appearance of that. So a test project could look something like this. It does nothing at all actually. Got a class name here. We've got 3 variables here. We can have private variables as well. None of these phrases, by the way. This is just total mock-up. And to avoid collisions with the the compiler, sorry, the IDE, the PB IDE, I think I'll go with calling methods. So when you create a variable or an element, an array of this class, the same as what you would do when you create a type. This will get called at that point, and what's going to happen, or what I hope we can get this to do, is the translator will run through this stuff here and go, okay, we'll make a PV version of this stuff here. So we've got three. We'll just cut that one there. They're out for the time being. These are public, so they would be accessible outside of this block of code. If it was private, you wouldn't be able to see it. So public and private are just about the visibility of these fields. It's the same concept of what we have as global and local, really. If we have local variables, they're visible within a function, and they're housed inside that function. They don't exist outside of it. And they have precedence over global variables. So tagging something as local means it uses the local version of that thing rather than the global version if one exists. In BASIC, it can be kind of ugly like that sometimes, but who cares anyway. So what the processor would do is it would create. Now I'm doing this on the fly, right? Absolutely. I've sort of messed this out the other day. So it would remove this other code above it. We would create a type of this. This would be our structure. So we'll add a bit of extra code here towards the bottom. So this is the definition of our class. We need to instantiate these things here. We need to create something of that class. We might have, dim variable A of class, whatever that was, sample class name. And just to show that we can have multiples of it running, we might have a second variable of type B, called B. That's the definition. Now we would go A, new sample class name, just like we would do with types. New sample. I've never got used to typing on the laptop keyboard. I don't know what it is. I just can't stand it. Right. So this would, by the time we got to here, A and B would be fully created and ready for use. We could do whatever we wanted with them. At the moment, we've got no syntax to mess around with, so we won't. We would use free the same way. We would free A. In other words, we're killing A and releasing all the memory that it uses. Just like with types. This stuff here is basically what you would do with types in PV anyway. That's why I want to keep that the same syntax. So what's below here is what the translator would create for us, ideally anyway. So it would run through and create these fields here. They would exist. They would be in here. We don't need public. That's an unused keyword in PV at the moment, even though it is highlighted by the IDE. Now, because these variables here are public, they would be called the same name, so you could easily access them at some other point. Now, we do have an object orientation, this idea of get and set methods, and we could have the same thing, I guess. So for any public variable or any variable at all, really, we could have like just a method here. You could shortcut it, I guess, get, and then the name of whatever, get some integer. in get. We might need, what you normally have is kind of a way of, well, cleaning up the input and out, a way of cleaning up an input and output of these things. So you always get an understood result. Whereas if I just read from the structure, I might get some answer that's not necessarily makes sense to me, but makes sense to the rest of the library in context. We'll go back to here to our translation. So we've got a very basic structure here. It would end up being called something else. It would give it a new name, class, whatever, sample class name. It would put this prefix in front of it, or suffix. Yeah. So it doesn't collide with any other names that you might have declared by some coincidence. It's still possible for it to collide, because you might actually decide to do that yourself for whatever reason. It wouldn't be very smart, the pre-processing tool. That would just be, would run through and do a pretty it would just butcher it together, and then it just leaves it up to the compiler to make sense of what was created. Anyway, so here we've got our basic structure of our class, and we need our methods. We've got two methods here that are declared. They don't do anything, which is neat. I think what I was thinking before is that, so these would become functions or subs, and this would be named, would have this long name here, and there would be a method of so we could just call this method function here. Yeah, in this version we'll just call it method. Right, so again we're using probably should call them all class method. I'm just thinking about the naming space, really. So they all exist in that same sort of block inside PB. It shouldn't matter too much. So this would be the constructor, and what this would do, actually, this would do something. It would return me as pointer. So here we go, me equals new this. That creates our object. We're not doing anything to it at this point because there's nothing in the constructor, and returns it for us. So our destruct is much the same. We don't have it doing anything much at all, but we have a free here. I would probably, we want to be passing this in. Doesn't exist here. So what the destruct would do is it would clean up any owned structures of this particular object. So if you use a sprite, for example, it would destroy the sprite. But you get to actually classify what this does. So if you allocated a sprite in the new method, here you would destroy the sprite. And that life cycle is complete. It has a creation, it has a death, which is all this program does. It creates a couple of objects and then destroys them for no real reason other than for an example. Okay, what are we talking about? So the free method here, we would have something like, yeah, we've got a free method. got our name, we're going to pass the object into here, do a bunch of stuff on it, and then we're going to go at the very end, me equals null. Or, sorry, we can do it that way, but we should use free in this case. And we probably should return a null at the end, a 0 at the end, so we can have this kind of same syntax. So this would be our class represented in PB code. Not very useful as such. These statements here would be converted to this. I hope you're sort of following what I'm talking about. So the dimension statement would be much the same. These declarations here, they most probably any object declarations, I would give them the object prefix. Really to avoid collisions with other just normal variables. If you had an object called A, it's kind of likely that you'll have something else called A as well. And there's a potential for collisions of the two names. Yeah, well, why not? So we could just call this object. Really, we could just actually pretty much mangle that name completely. We can make it some weird abstract thing that gets inserted everywhere that you're very unlikely to have collisions against. So what happens when we allocate this thing, we've defined this thing in, this is actually that structure there is wrong, isn't it? What do we call this? Call it class. Okay. So this would be class as pointer. So we've got two definitions of these pointers. And now we need, I can see a problem with that straight away actually. There's a scoping problem with pointers. Yeah, well. And what it would do anyway is it would generate for our new, you probably already guessed, but it would generate this. So A would become this thing. And B would call the same method as well. Every time we call it, we're doing something cool. And to get rid of them, we'd get rewritten as, object. Isn't that what I just called them? Object A. And it returns a value as well, so it probably would be phrased or set up like this to make sure that version of that variable is now null or 0, which in PB terms is the same thing. There's no differentiation between the two. Excuse me. Alrighty, that gives us pretty much a representation of what the preprocessor would create for you. At this point, it's not much different than just having a type, but it can generate some cleanup code for you and do this kind of stuff. So you could do things like, let's say you have I can't think of a usage case that makes any sense in this context. So let's say you've got, in our pretend class, we've got a private integer array, we'll just call it. That's my variable name, and it's one-dimensional. It's dynamic. It's created as this object exists. Now, as this thing is running, so A and B would have their own one-dimensional array inside them. Now, we'll make this public. make this make any sense at all. Now, let's say that when we create this object, we might do something like this. We might dimension the array to, size. So we'll have dimension size. And here, we wouldn't need to clean this up actually, we wouldn't need that at all. And we would need here, since that the new operator actually has an expectation of there being a parameter now, we need to pass it some parameter. So this one here can have an array of 100 items, this one here can have an array of 200 items in it. For whatever reason, I have no idea why excuse me, it's like 3 o'clock in the morning, I'm stuffed. Why we might want to do that. I'm actually serious, I'm so exhausted, it's not funny. What are we doing? Yeah, let's get into it. So now what we would do here is this field would be handled as like a dynamic array, and it would do it like this. So we'd have, that's the name of our thing, and this would be, but it would have a differentiation where there would be array handle or something like that. So during the new process, or the function anyway, what it would generate is some code that does this for us. So that dimension statement that we saw up here is going to be implemented like this. This needs a parameter here of size. So now we have, so me has been created, and sorry, that was integer array. Integer array handle. Okay. What we have to do is generate a handle for you. So one way to do that, or probably the most convenient method, is to do something like, I'll just call this create array for whatever reason. So this array, this little helper function is returning an array handle back to the caller. So in here we just have temp size. And this is kind of the approach you meant to use, by the way. So to do this, to create this array inside our object, we're doing this. That gives us the same behavior. Now this object has its own dynamic array. We can use just like temp, but it's going to be implemented in these using array handles rather than an array directly, as we're probably more comfortable using. Now when this thing is destroyed, we have to create some code, well, I guess it doesn't have to. Sorry, it wouldn't have to. Yeah. You wouldn't have to have an undim in the free here, for example. You could, right? And that would make sure that this thing here is released when this object is freed. So we're freeing all of the dependent data that this object is holding and it's pointing to, or since it's an array, it could just generate this for you anyway. So where was our free routine? So what it could do is it could go, what was the thing called again? Integer, yes, good. Thanks very much for that, NBN. It could check the handle, which means that if you've deleted this thing up front for it, then it will already not exist. But in case you haven't, right, we can do like a make array, you know, and we'll call this one, sorry, make array temp, which is a container for this basically, and we hit here and we go temp equals. So we'll generate this kind of boilerplate for you, which is kind of neat, really. It's handy sometimes and a pain in the ass other times, I guess. This here we could have a write 0 to clear that out. So this would release that array safely for you. So we're creating this handle array, or this empty array container pretty much. We're assigning it an array created somewhere else now, which means that temp now behaves just like it was dimmed. Yeah, if you dimmed temp, you know, with your size, or temp1, temp and temp1 would behave exactly the same way. The only difference is that temp doesn't own the handles that you've associated to it, so you can use it to look at data from other arrays, or lots of dynamically created arrays, which is why, I know it's awkward, I know it's an old mechanism, but it does work. You can use this. I've used this quite a bit actually. So that would get rid of the dependent array, and the code below here would not change. Except the sizes here would need to be passed in for us. Hope that makes a bit of sense. Probably doesn't make a lot of sense. I'm almost falling asleep. What else I want to talk about? I guess pretty much it really. Just the pre-processing stuff. I've been looking for some faults in PB. The array passing one, I still can't work out why the hell that happens. Frustrating. Hopefully we'll find some of these big ones. We'll mess around with this project here. The tool itself is just grabbed some libraries that I've written for other projects. The lexical scanner here is actually from, originally it's from DTAB 6 years ago. I wrote a basic compiler for my drumming application to handle the scripting side of when you give it a URL, so it downloads the page and then applies the script to the page to grab the specific parts of the text out of the page, because they were very different, and I thought if I tried to build that stuff in, it was just tiresome. So having scripts was much easier. And this is a loose port of that code. That was written in Visual Basic, by the way, VB6. And then it was ported and used in the OpenGL library. That's what the particle script here, token stuff, is all about. The compiler itself doesn't really do much. Got a bunch of stacks setting up, a bunch of declarations, and really, yeah, there you go. This is it was originally the G2D load particle script function. so we're going to butcher this in try making it run through our code and generate some code for us. I don't know how far we'll get with it. I'm not expecting it to do a lot with it really. I just want to check it. Just want to give it a go and see if it does work and what will fit into the model. And if it does work, then you can do all kinds of weird and crazy stuff. I mean, as I said before, I've written a lot of these pre-processing tools before, and they are sometimes they're a bit of fun, but they can really take your project and accelerate where you are with it. Sometimes they don't. Not always. Sometimes they make life harder, I guess, because you have multiple projects and you're building part of one as a library of it that's used in another one. You're using a secondary tool to generate the code used in the other one, etc. A lot of messing around. Yeah. Anyway, that's enough for today, and hope you're enjoying yourself, and hope the world isn't too crazy for you at the moment. It's calmed down here a lot, so hopefully we can get back to some sort of normality. That'd be nice. Anyway, stay cool. See ya.